The first dinosaurs are taking over Pangaea more than 200 million years ago during the late Triassic. But these giants are not the only astonishing animals to inhabit our Earth. As the continents constantly collide and drift apart, life in the ever-changing seas is also developing in astonishing diversity. Algae and corals have long provided food and habitats in the water, even before the first plants appeared on land. Already 500 million years ago, sponges and early fish inhabit the cool waters, laying the foundation for more complex life. The late Devon, more than 350 million years ago, is not only a time long before mammals, but there is also no trace of dinosaurs on the blue planet. Life still takes place mostly in the water. On the still scattered continents, arthropods dominate, such as giant millipedes, prehistoric scorpions, and wingless ancestors of insects. While the first forests are beginning to emerge on land, the seas are home to gigantic armored fish like Dunkleosteus. At up to 4 meters in length, the largest known arthrodire can reach a weight of over 1.5 tons. This group of armored fish is the youngest and thus likely the last of the placoderms, which will already be extinct by the beginning of the Carboniferous. So far, at least 10 species of this genus have been described, making Dunkleosteus one of the most species-rich groups of armored fish. The skull and neck region of Dunkleosteus are covered with strong bony armor, which can reach up to 7 centimeters in thickness. Its massive jaws are particularly striking. However, these jaws do not have teeth. Their function is taken over by 4 continuously growing bony plates, which are capable of sharpening themselves. The powerful bite of Dunkleosteus is further enhanced by its ability to open and close its jaws quickly. In this way, prey is rapidly sucked into its mouth and swallowed whole. Thanks to its efficient hunting strategy, Dunkleosteus becomes one of the very first vertebrate apex predators. Dunkleosteus earns this reputation from a young age. Even the lower jaws of juveniles are, proportionally, as robust as those of adults, allowing them to cut through tough prey tissue. Its tail fin is heterocercal, meaning asymmetrical. The upper lobe is enlarged compared to the lower, similar to sharks. Since early fish like Dunkleosteus still lack a swim bladder, this fin shape provides slight lift, allowing the fish to hover in the water, which is also advantageous when hunting. Its name honors the paleontologist David Dunkel, who worked with the fish's fossils at the Cleveland Museum of Natural History. The osteus part means bone. As robust as Dunkleosteus may seem, it is not invincible. The so-called Hangenberg event at the end of the Devon ends its lineage. This event is a period of major changes lasting thousands of years. Climate change and severe oxygen loss make the seas anoxic, plankton and corals die, small fish vanish, and with them the food supply for Dunkleosteus. A mass extinction follows, yet the world of the seas will recover. In the Carboniferous, which follows the Devon, Forests continue to grow on land, and oxygen production rises due to increased photosynthesis. The land becomes a stable habitat, and the first large terrestrial animals begin to inhabit the continents. In the following Permian, reptiles continue to evolve, the seas initially stabilize, and the ancestors of later marine reptiles appear. Yet another crisis strikes both land and waters. At the end of the Permian, the largest mass extinction in Earth's history occurs, the Permian-Triassic crisis, and a new era begins. About 230 million years ago, during the Middle Triassic, the world is much drier. The continents are united into the supercontinent Pangaea, whose coasts are rich in lagoons, river deltas, and warm, shallow seas. It is here that Nothosaurus lives, filling an ecological niche after the last mass extinction and benefiting from little competition. Its streamlined body reaches a length of 7 meters, making it ideal for gliding quickly through the water. Using its tail and the webbing between its toes, it steers gracefully through the shallow seas. Yet Nothosaurus is also adapted for short excursions onto land. As a cold-blooded animal, it uses this opportunity to warm its body under the sun and store heat. These pauses are also useful for breathing. Like modern reptiles, Nothosaurus must regularly surface for air, but for hunting, it specializes in fish and other small marine animals in the water. With its flexible neck, it performs rapid movements and is able to track its prey with a fixed gaze. Rocks and seaweed beds allow Nothosaurus to approach fish and ammonites unnoticed. Its long, narrow jaw is equipped with sharp teeth. The jaw muscles are perfectly suited for snapping at and holding prey, much like the hunting style of crocodiles. While Nothosaurus unites life on land and in the water, terrestrial animals continue to evolve as well. By the end of its time in the late Triassic, the lagoons gradually dry up and wide rivers cut through dry plains. The first dinosaurs adapt to this environment. About 210 million years ago, the age of the true dinosaurs gradually begins. What had previously been dominated by reptiles and insects now becomes the realm of slender and agile hunters. In present-day New Mexico, it is dry and warm during the late Triassic period. Open plains are cut by wide river systems, and here and there, sparse forests provide shelter, food, and living space for herbivores. And where herbivores find a home, their predators are never far away. Coelophysis belongs to the first representatives of the dinosaurs, which will continue to populate our planet for hundreds of millions of years and eventually reach gigantic sizes. Yet this delicate theropod is still a lightweight in comparison. It does not grow larger than about 2.5 meters and weighs a mere 20 to 30 kilograms. Coelophysis runs differently from its reptilian ancestors. It walks on 2 legs positioned directly under its body instead of sprawled to the sides. This allows it to reach significantly higher running speeds and to move for longer stretches without tiring. Its hollow bones further reduce its weight, while its long tail acts as a counterbalance. The skull of Coelophysis is narrow and low, with forward-facing eyes that improve its depth perception. Its vision surpasses that of most lizards and is comparable to that of modern birds of prey. Its jaw holds numerous small teeth with piercing tips. They are finely serrated on both the front and rear edges, leaving prey no room to escape once bitten. Because of its size and relatively weak arms, it mainly hunts insects, small amphibians, and lizards. During its hunts, Coelophysis relies on keen eyesight and therefore prefers daytime as its hunting period. Today, it is thought that Coelophysis at least occasionally lives in groups. Whether these groups are formed specifically for cooperative hunting or rather for protection during migrations is not yet conclusively determined. However, the discovery of large assemblages of individuals, true mass graves, suggests that Coelophysis was not a strictly solitary animal, and intraspecific competition probably did not play a dominant role. In any case, Coelophysis today is one of the best-studied dinosaurs of the early Triassic. Since its discovery more than a century ago, it has held a firm place in paleontological research and literature. In 1981, it was even designated the official state fossil of New Mexico and still features in the logo of the local Natural History Museum. Life in the seas also continues to evolve, though in a completely different form. Terrestrial vertebrates and marine reptiles both descend from reptiles, but early on, they follow separate evolutionary paths. Some remain on land, becoming faster, larger, more diverse. They become the dinosaurs. The others return to the water. In the endless open seas, they develop new body forms, new strategies, and new ways of life. They lose the need to ever return to land. From them, the marine reptiles emerge, fully adapted swimmers, shaped for gliding through currents and the depths of the ocean. One of the most elegant representatives of this lineage is already gliding through the waves of Europe 200 million years ago, Ichthyosaurus. It is one of the first marine reptiles to achieve full adaptation to life in water. Unlike Nothosaurus, it no longer ventures onto land. It even gives birth to its young alive in the water. It only needs to reach the surface occasionally to breathe, since as a reptile, it has lungs and no gills. Its descendants will one day be much larger than the first Ichthyosaurus, yet it is no less impressive. At a length of 2 to 3 meters, it rarely weighs more than 100 kilograms, and its streamlined body resembles modern dolphins. Its back carries a fleshy dorsal fin that helps stabilize it, while the broad forefins provide precise steering. Most of its propulsion comes from the strong, crescent-shaped tail fin, which catapults it quickly and efficiently through the water. This tuna-like mode of locomotion makes Ichthyosaurus an enduring pursuit predator. Its ears are solidly built and serve to perceive vibrations in the water. It also relies on its eyesight during hunts. Ossified shields around its eye sockets protect the eyes of Ichthyosaurus. Unlike Dunkleosteus, this marine hunter does not suck in its prey. To catch prey, the reptile opens its mouth and shoots toward its victims at impressive speed. Already during forward motion, it grabs them with its sharp teeth, and its narrow snout facilitates precise grasping. In this way, Ichthyosaurus feeds primarily on fish and cephalopods, such as early squids. As with Coelophysis, fossil finds of groups suggest that ichthyosaurs were not strictly solitary. They probably moved in schools similar to dolphins or small sharks, both for protection from larger predators and to hunt cooperatively. It is also possible that the groups gathered only seasonally to travel long distances or to give birth to their young in safer environments. Today, however, this can only be speculated. But Ichthyosaurus is not the only fully aquatic reptile. In the same seas, a competitor already towers over it in size. Plesiosaurus makes its rounds in the open coastal seas, bays, and shallow waters of Europe. Like Ichthyosaurus, it is a marine reptile whose life takes place entirely in the water, but at up to 4 meters in length, it is significantly larger. It also has a different body shape. While its torso is similarly streamlined, the 4 paddle-like limbs make it resemble a turtle. At the end of its long neck sits a slender, elongated head. At the rear is a relatively short tail with a fin that helps steer its bulky body. The 4 limbs of Plesiosaurus, on the other hand, provide propulsion. But instead of simply paddling like modern ducks, it practices what is called an underwater flight. Like penguins and sea turtles, it generates different pressures above and below the fins. The power for this comes from its well-developed chest and pelvic muscles, which are especially strong in Plesiosaurus. It uses this endurance primarily to hunt fish. Its flexible neck assists in this task. However, precise movements upward and sideways are limited, while the downward range is much greater. This suggests it may also have searched for food along the seafloor, such as ammonites, bivalves, and crabs. It is confirmed that Plesiosaurus hunts visually, relying on its eyesight, as evidenced by the large size of its eyes. Since plesiosaurs also do not come onto land, it is assumed today that they do not lay eggs. Their skeletons could not support them on land without the buoyancy of water, and their lungs would collapse. Like ichthyosaurs, plesiosaurs give birth to live young in the water. The discovery of a juvenile in the body cavity of an adult plesiosaurus shows how large the offspring already were before birth. Since the young measured about 1/3 the size of its mother, it is likely that plesiosaurs give birth to only a single offspring, and that this young is not left to fend for itself. Much evidence suggests that mother and juvenile remain close together during the first weeks of life. In an open sea full of predators, a newly born juvenile would be highly vulnerable, as even adult plesiosaurs could fall prey to larger, more aggressive hunters. Staying close to the mother provides protection, orientation, and the opportunity to learn from her movements, hunting techniques, and resting periods. Young plesiosaurs may even have remained in small family groups, similar to many marine mammals today. Although we do not have direct behavioral traces, the combination of large juvenile size, slow development, and the physically demanding birth process strongly indicates that plesiosaurs invest in their offspring and practice extensive parental care to ensure their survival. And over the next millions of years, this would become increasingly important. Among the now significantly larger ichthyosaurs, sea turtles, and early sharks swims another giant of the ocean, Attenborosaurus. It lives during the early Cretaceous, about 125 million years ago, in the waters around what is now England. The world is more fragmented. Pangaea has long since broken apart, and the continents are slowly approaching the positions we know today. The seas are warm, vast, and full of life, but that also brings certain dangers. For this reason, Attenborosaurus is specialized for more powerful hunting maneuvers than its relative Plesiosaurus. It can reach a length of about 4 to 6 meters and also has a relatively short but still flexible neck. Its head and jaws are strong and equipped with conical teeth. Attenborosaurus is probably more aggressive than Plesiosaurus. It also uses its 4 powerful paddles for underwater flight, propelling itself like a torpedo through the waves. In this way, it seizes its prey and bites firmly. With this technique, it can also take larger targets, such as bigger fish and squids, but also the juveniles of other marine reptiles. The waters of the early Cretaceous are far more productive than they were 50 million years earlier. This means more food, but also more competition. And with competition, the shadows of predators grow. The marine reptiles of prehistoric times are no longer gentle giants. With each generation, they become faster, stronger, and better adapted for hunting, until they no longer focus solely on fish.